Hi class, today you're going to be starting your mineral identification lab on pages 6 and 7 of your packet. So please take out your green packet. This is it, mine's just not green. Today we're going to flip to pages 6 and 7. The first thing that we need to do for this lab is to identify our problem. In the back of the lab, each lab group has 10 different minerals. Your job today is going to be to identify these minerals based on their color, streak, hardness, luster, cleavage, or fracture. We will spend today and a little bit of tomorrow in class working on gathering the data for this lab. Currently, we're working on our problem. So our problem today is to identify minerals based on their physical properties. These physical properties again are going to be color, streak, hardness, luster, cleavage, and fracture, and the other we'll do in class tomorrow. Each of the minerals in the back has a little painting on it with a number. This will tell you which sample number you're dealing with. So you guys are going to have 1 through 10 today. In the color box, you will write down the color of the mineral. Let's look up a mineral just for fun. Mineral. So here's 4 different minerals. This one might be ruby. This one might be purple. This one might be yellow. This one might be gray. Those colors would go in your color box here. The next thing you need to do is find the streak of each mineral. If we go back to streak right here is the powdered form of a mineral.
To measure streak, you need one thing, porcelain. Take the mineral and rub it on the porcelain. Whatever color shows up is the color of the streak. If you cannot see the mineral with the white porcelain, use the black porcelain to measure the mineral streak.
You record your streak right here. That will be the color of the mineral in powdered form. For example, on the one the girl did on the black porcelain, it would be white. If you do not have black porcelain, you can run your finger over the top of the plate and look at the powder on your finger. The next thing you will find is hardness. The hardness of an object will be written in range. For example, 2.5 to 3.5. Or you might have less than 2.5. Or you might have greater than 5.5.
Alright, so this is Vcast 6 looking at mineral hardness. Again, we're working up to being able to identify a mineral based on all of its properties. And this one, you're looking at the hardness of a mineral. Hardness of the mineral is just basically what can that mineral scratch compared to others. Alright, the hardest mineral can scratch the softer mineral, and it ranges from a 1 being the softest to a 10 being the hardest. If you look on page 52 in your book, you're going to find the Mohs hardness scale, and it'll describe what minerals have what values. But really what we're going to be doing is not scratching these minerals against other minerals, but against these objects right here. A streak plate, a glass plate, an iron nail, copper penny, and your fingernails. Okay? All of those have a given hardness value that you can compare these minerals to. We're going to do 3 in this vodcast. So first off, what you really need to do is determine if a mineral is hard or soft. All right. All hard minerals can scratch glass. Soft minerals can't. And just like in the streak test, what you're going to be doing is, for the glass, you're going to be taking that mineral and seeing if it can scratch it or powder onto it. You do not want to hold it in your hand because you may be pushing very hard on some of these. So do not hold this in your hand. Again, if I see that, you'll be done for the day. So let's go ahead and jump into it. If I want to know if a mineral is hard or soft, I'm going to take that mineral in one hand. We're going to start with a glass plate held down on the table. You're going to push hard enough so that one of two things happen. Either this mineral will scratch the glass, or this mineral will powder onto it. Those are your only two options. If you don't push hard enough, nothing happens, and that's not a result. All right, so if you push hard enough, all right, well, there's some white powder on it that I can wipe off. All right, so really what I've done is determine that this mineral is softer than this. It did not scratch the glass. It left a little powder that I wiped off. This is definitely softer. Let's go with this next piece. Hold it down, and I usually look for a corner or an edge. Don't do it on the flat surfaces this way. All right, push down hard until either this powders or it scratches it. And again, some white powder. This is softer. Try our third mineral. Find a good spot. Alright, you can even feel and hear a difference with this mineral. All right. You can see that it did leave a white streak, but this time, let me hold it up. It's hard to see in here, but right here, I can rub my fingernail across and see that it actually left a little gouge in it. That shows that this mineral actually scratched the glass. So this is harder than the glass. The glass is a 5.5, and you do need to know all of the hardness values. So that means this must be at least a 5.5, 6. All right. If it's the same value, they'll scratch each other. But this is probably harder. So this is a hard mineral. This is most likely a 6 or above. These are soft. Now that's usually going to be good enough, but sometimes you do need to get it down to the exact hardness. So I can test this hard mineral real quick and see if it actually scratches the streak plate. Now, you'll either again feel that there's a scratch in it, or it's going to powder onto it and not leave that scratch. Push hard. All right. I don't feel with my fingernail and a scratch, and I do see a bunch of white powder. So this did not scratch the streak plate. Very few things will. So since this is a 6.5, this is a 5.5, it could scratch this, but could not scratch that. So it's in between 5.5 and a 6.5, which makes this a hardness of 6. So that one's done. Now these guys were not able to scratch the glass. So they're soft minerals, and that means we're going to compare them to an iron nail, which is 4.5, copper 3.5, and fingernails. You can work your way down, but in order to save some time here, all right, I can just, instead of trying to scratch the iron nail, I can take the iron nail. Oh, that definitely scratched it right there. Same thing there. All right, that means these are both softer than the iron nail. This is 4.5, so these guys are at least 4 or lower. The copper, all right, it's nice to get a nice shiny penny, and it's either going to leave a gouge in this or it's going to powder. Push a little harder. See, nothing really happened. It just kind of knocked the tarnish off, so I need to push even harder. There we go. And we have white powder. So, softer than that. Also, white powder. So that is softer than the 3.5. So these are both less than 3.5. Now you're down to your fingernails. You can either use these as like a streak plate, or you could try to scratch it with your fingernail. So if I take my thumbnail and push down, really not easily able to scratch this. So what I can do instead is use my thumbnail as a streak plate, pushing down hard, and feel that it's left a nice little groove in there. All right. So this is definitely harder than my fingernail. So this is more like a 3, since my fingernail is 2.5, and this one can easily scratch with my fingernail easily. So this is much less than my fingernail. This is more like a 2, maybe a 1.5. Alright, so that is the hardness test. Master it, move on to the next one.
You'll write your hardness again in this column right here. The next thing you need to do is figure out the luster of your mineral. Your luster is either going to be an M for non-metallic or M for metallic. Our NM non-metallic minerals are going to not look like metals. They won't have that shiny metal look, and our metallic ones will have a shine that is like a metal. If it's just shiny like a piece of glass, that's going to be non-metallic. The next thing that we're going to do is determine if our mineral has cleavage or fracture.
Determining cleavage or fracture in a mineral sample can sometimes be pretty difficult. So the more you practice with this, obviously, the better you'll get. Here's a straightforward example. This is muscovite, it's a type of mica. Muscovite has, what we say, one plane of cleavage. So cleavage is looking for how many natural planes that a mineral has. In this case, you can see muscovite has one direction, in the direction that my pencil is going. If you turn it on its side, you'll see that one direction of cleavage. Compare that to something like halite, which is rock salt. When you look at the sample of halite, you can clearly look for those natural planes of breakage. We've got one plane here, which is parallel to this plane, so we look at the parallel planes together. One plane, two planes right here, and a third plane here and here. So we say this has 3 planes of cleavage. Compare that to this mineral. This is fluorite. Fluorite has 4 planes of cleavage, so sometimes it's easiest if you get a little flash of light to reveal the flat surfaces. Here's one direction, here's a second direction, third direction, and this would be considered the 4th direction of cleavage on this particular sample. Sometimes you might find a sample such as this, and looking at this you might say, wow, I've got 1, 2, 3, 4, 5, 6 planes of cleavage, right? No, you don't. You actually are looking at a crystal faces, which look like flat planes, but they are formed not by breakage. They are actually formed as the magma cools. So what you want to do is look for where the natural break in the sample is, and it's on the end. You look at this, it's rather irregular, and you can call this fracture. Here's another example of fracture. This fracture is glassy and got kind of a scooped out shell-like look. We call that conchoidal fracture. You'll look at some other examples of fracture and cleavage in your lab.
As you're looking at your cleavage and fracture, you can just put a capital C or a capital F in these boxes. C for cleavage and F for fracture. You guys already have your lab partners. You will be working with your elbow buddy that's sitting next to you. Last class we assigned lab stations. Mr. Menifee knows where your lab station should be. For this lab you need to be engaged and safe. Engagement in this lab looks like staying at your own station and testing each and every mineral. Safety for this lab looks like not holding that glass plate in your palm, not moving any supplies or throwing supplies, not poking your fingers with the nail that's in the hardness test, no horseplay. I think you guys got it. Good luck.